welcome to the Glendale Community College Virtual Planetarium powered by Skyscan's dark matter software. Today we'll be investigating gas and dust. No, wait, don't close the browser window. This is not a lecture about cleanliness and digestive health. You can have that talk with your friendly neighborhood gastroenterologist. This presentation is about nebulas. What is a nebula, you ask? The word nebula actually means cloud, and in astronomy it was originally used to describe anything that looked cloudy, blurry, or fuzzy. This could include anything from galaxies to poorly resolved planets or star clusters. Today we use the word to signify accumulations of interstellar dust and gas. The space between solar systems usually does not have much material in it, but there are some areas where the scarce material is a little denser. These accumulations of material are what we call nebulas, or nebulae. Either pronunciation is acceptable. Nebulas follows the rules of the English language. Nebulae follows the Latin rules. Now you may be wondering where nebulas come from. There are a few sources. One type of nebula is called a molecular cloud. The clouds are mostly made up of molecular hydrogen. In chemistry, molecular hydrogen is written as H2. That means that hydrogen atoms are paired up. Molecular hydrogen is notoriously hard to detect from a distance, which would make molecular clouds invisible to us. Luckily, these clouds also contain small amounts of carbon monoxide, the same stuff you don't want building up in your home. Carbon monoxide detectors, by the way, are a simple way to keep a broken furnace from poisoning you while you sleep. Something you might want to pick up while you're shopping for those formal pajama pants to wear to your next online meeting. This funny-looking map overlaid on our sky shows where the carbon monoxide is most concentrated. Basically, this picture tells us that our galaxy has lots of gas. The dark red areas follow the plane of the Milky Way. In these areas we find clouds like the Omega Nebula. So how do we wind up with these dense gassy regions? In a word, gravity. Most of us think of gravity as the force that keeps us attached to the Earth and lets us know which way is down. More generally, gravity pulls stuff together. If you scatter anything in an empty area of outer space, that stuff will be pulled together and will pile up eventually. This happens to molecules. The Omega Nebula is an example of such an accumulation of gas. Stars, by the way, are also made of gas. Stars are in fact made in nebulas. This is happening right now in the Orion Nebula and many others. Gas clumps together inside of nebulas and gravity compresses these clumps more and more until stars form. So now we know that nebulas can form stars, but stars can also form nebulas. Stars don't last forever. Ours will be around another 4.5 to 5 billion years, but even the sun will eventually run out of fuel. Every star does at some point. One might guess that a larger star would have more fuel, so would last longer. But in fact that is the opposite. Stars much larger than our sun use up their fuel quickly, become unstable, and explode. I will omit the details since it's the explosion's aftermath that we are interested in right now. Astronomers call the explosion of large stars supernova explosions. Nova means new, and super just means that the explosion is huge. It is so huge that we can detect these explosions when they happen in our neighboring galaxies. After the explosion, all that is left is an ultra-compact core and a gigantic cloud of gas. One example of this kind of nebula can be found in the constellation Cassiopeia. It is quite impressive when viewed in visible light. In addition, it is a source of X-rays, as seen in this Chandra telescope image. Not every star will end its life in such a dramatic fashion. Our sun, for example, is too small to produce such a massive explosion, but it'll still blast off some gas. This event is known as a nova, and it will also produce a nebula. These types of nebulas are smaller and don't last as long. They are known as planetary nebulas. The reason they are called planetary is that shortly after Uranus was discovered, people looking at nebulas thought they looked like distant planets. An example of a planetary nebula is the Cat's Eye Nebula. Planetary nebulas come in different colors, but they are all known as emission nebulas. Emission nebulas are one of 3 recognized types. We will take a look at an example of each. Emission nebulas include the Cat's Eye Nebula and the Eagle Nebula. If you are having a hard time seeing the eagle, maybe this will help. At any rate, emission nebulas have one thing in common. They all emit light, hence the name. The gases in the emission nebula absorb energy from nearby stars and from the explosion. They then re-emit the energy as light. Another type of nebula is a reflection nebula. These nebulas do not emit their own light. Instead, they reflect light from nearby stars. A good example of a reflection nebula is the Witch's Head Nebula. If you're wondering about the name, it came from what looks like the profile of a witch's head. There is nothing scientifically significant about the details of the shape. It's just us humans having a little fun. Finally, we have dark nebulas. This may sound a little ominous, but there is nothing scary about dark nebulas. A good example of these is the Horsehead Nebula. See the horse? This type of nebula does not emit or reflect much light. Instead, it blocks light from luminous objects behind it. I should mention that in this context, light is used to mean visible light. The Horsehead Nebula is actually quite bright in the infrared. I hope you have enjoyed your time in the clouds. Have a great weekend.